Pre-Calc students, welcome to today's lesson on evaluating trig functions without the use of special right triangles. So I want to just remind you guys that any ordered pair on a coordinate plane has value in terms of trig. For example, the x value of an ordered pair is equivalent to the cosine, and the y value is equivalent to the sine of an angle. So think about the x-axis, right? When you travel to the left, the x values are negative. So in those quadrants, which are quadrants 2 and 3, cosine is negative because the x values of those ordered pairs are negative. Whereas in quadrants 1 and 4, the x values are positive, so cosine is positive in quadrants 1 and 4. Now let's look at the y-axis. As you go higher on the y-axis, the y values are increasing, right? In quadrants 1 and 2, the y values of any ordered pair are positive. So all the sine of those angles, sine of any angle in quadrants 1 and 2 is going to be positive. Vice versa, if you have the sine of an angle that's in quadrant 3 or 4, those values are going to be negative. So that's going to be useful information today, along with the fact that tangent of theta is sine over cosine, aka y over x, and cotangent is x over y, cosine over sine. So we've discussed all this stuff before, and the ordered pairs being positive in quadrant 1, negative positive in quadrant 2, all of that is common sense based on the axis and which way you travel. So we're going to kind of see how that applies to our lesson today. Go ahead and read the directions for number 1 and plot the ordered pair -3, 4. Okay, so the only thing they told us is that the ordered pair is on the terminal side of an angle. We don't know if the angle is positive or negative. Okay, so we don't know if the angle went down and around and is negative, or if it went up and around and is positive. Okay, but what is important is that they're asking us to find the secant of that angle. Well, in order for me to do that, I need to, if they're asking you for secant, which is hypotenuse over adjacent, I need to have a triangle. So to draw my right triangle, I take the terminal side and drop it down to the x-axis. My reference angle, or theta in this case, is always an acute angle from the terminal side to the x-axis. Okay, so technically that's theta prime, but that's the angle we're going to be working with for the right triangle. Okay, because the original angle, we just don't know where it was. We don't know if this was theta, right? If the original angle was positive or negative, but that's not really important. We don't need to necessarily know if it was positive or negative. We just need to know that the reference angle, which is an acute angle from the terminal side to the x-axis, is what we're going to use to find hypotenuse over adjacent. All right, so I'm going to fill in the side lengths for my horizontal distance, which is the leg that went left 3, so that value is -3. I also know that I went up 4, so that value is +4. And my job is to find the hypotenuse, so I can do a hypotenuse over adjacent. So I'm going to do Pythagorean theorem, a squared plus b squared equals c squared. So leg squared plus leg squared equals hypotenuse squared. 9 plus 16 is 25. Square root that, and you get 5. Remember, the hypotenuse is always positive when you're dealing with triangles in the coordinate plane. So my final answer is going to be 5 over -3 or -5/3, right? Because hypotenuse over adjacent gives me -5/3. Okay, go ahead and plot the ordered pair 2, -3 for the next example. What quadrant is it in? What quadrant is 2, -3 in? So 2, -3 ends up being in quadrant 4, right? But again, we don't know if the angle went up and around and the angle's positive, or if the angle went down and around and is negative. The important thing to remember is, in order for me to find the sine of this angle, I need opposite over hypotenuse. So I need the values for a triangle here. Well, how do we draw the triangle? You drop the terminal side to the x-axis. That's going to be perpendicular. You're going to use theta as your reference angle, which is from the terminal side to the x-axis. Remember, it always has to be less than 90 degrees. You're going to fill in your side lengths. You want 2 to the right and 3 down. And since it's asking for a sine, I need the value of the hypotenuse. So a squared plus b squared equals c squared. 4 plus 9 is 13. Unfortunately, you can't square root 13 and get a perfect answer. It also doesn't break down. So we just get the square root of 13. So opposite over hypotenuse, using theta, which is the reference angle, technically theta prime, is -3 over root 13. But it is improper to leave roots in the denominator, so you need to rationalize. Your final answer should be -3 root 13 over 13. Okay, so let's take a look at number 3. Pause the video for a second if you need to and read the directions for number 3. Pay attention to what information was given and how you might use it to help you find the cosecant of theta. Okay, so cosine of theta, remember cosine represents the x values, right? In a coordinate plane. It also represents adjacent over hypotenuse. So this piece of information tells us a couple of things. It tells us that the x value is negative. So the only places where the x values are negative are quadrants 2 and 3. The other piece of information will help us decide whether it's 2 or 3 where we're going to draw our angle. Since they said the sine of theta is less than 0, that means that it is negative. Okay, so the sine value is negative. Now, what does that mean? Well, sine is negative. And sine represents the y values, right, in ordered pairs. So in which quadrant, 2 or 3, are the y values negative? The y values are negative in quadrant 3. So that means we're going to be drawing our triangle in quadrant 3. Okay, so we're going to be making sure we draw our triangle in quadrant 3. Okay, so let's go ahead and draw it. Now, cosine of theta, so our reference angle, now it's okay if it's not perfect, guys, okay? Our reference angle is always going to be from the terminal side to the x-axis. Okay, from the terminal side, that's going to be our theta prime, or theta, our reference angle. And all we know is that adjacent over hypotenuse is -4/5. So adjacent, whenever you go left, those values are negative. Over hypotenuse, that's 5. Now what we need is we need to figure out that other length, since they're asking for they're asking for cosecant, which is hypotenuse over opposite. Okay. All right, so the given information is supposed to help you figure out what quadrant the terminal side of the angle is in, so then you can draw your right triangle, find any missing pieces. So a squared plus b squared equals c squared. So that's 16 and 25, subtract 16. And you get 3 as your other side length, but it's going to be -3 because it goes down. Feel free to put tick marks if it makes you feel better, but you don't really need them. Okay? Now, using your reference angle, which is always from the terminal side to the x-axis, always has to be acute. What is hypotenuse over opposite? Hypotenuse over opposite. You should get -5/3. So the given information is supposed to help you decide what quadrant you're going to be working in. Okay, so in this next one, they told us that tangent is negative. Well, how is tangent related to x and y? Tangent is the y value over x. Y over x. So if your answer is negative, then only one of these values could be negative. So that means that they can't both be positive or both negative. Okay? So this information, the fact that the ratio of y over x of the ordered pairs, right? Think of the y value and x value. The fact that it's negative means it cannot be in quadrants 1 because then tangent would be positive because you'd have positive y's over positive x's would be positive. So it can't be quadrant 1. It could be quadrant 2 because here the x's are negative, right? And the y's are positive. So y over x would be negative. It could also be quadrant 4 because there the x's are positive and the y's are negative. So the point is, guys, that you want to pick the quadrants where the ratio of y over x would be negative. So you can't have it be in quadrant 1 because the x's and y's are both positive there, and positive divided by positive is positive. They can't be in quadrant 3 because negative divided by negative would be positive. Remember, we want y over x to be negative. Now, between these two quadrants, which one is it going to be? Well, that's where we use this other piece of information. They're telling me cosine is greater than 0. That means cosine is positive. Okay? And cosine has to do with the x values. So I don't want quadrant 2 because there the x values are negative. All right, so now we have to draw theta from the positive x-axis. It doesn't have to be perfect, so draw a terminal side in quadrant 4. And we know that opposite over adjacent, so finish drawing your triangle, doesn't have to be perfect. Opposite over adjacent has to be -5/6. So which of these has to be negative? It has to be the 5 because it's below the x-axis. The 6 is on the positive x-axis, so that is positive, and then the 5 you went down, okay? So sine is opposite over hypotenuse. So I need to find the hypotenuse in order to finish the problem. So go ahead and pause the video and find the missing side, which is the hypotenuse, for that triangle. Push play when you have found that hypotenuse length. All right, so the hypotenuse is square root of 61. So now I'm going to fill it in, and I can find opposite over hypotenuse using theta. Opposite over hypotenuse. Rationalize. And you get negative 5/61 over 61. It stays like that because you cannot reduce negative 5 over 61. Okay, so notice that in number 5, they told us that the cotangent of theta is undefined. This means that there was no triangle here. This had everything to do with the quadrantal angles. So I'm going to think back to my quadrantal angles and figure out which one has a cotangent that is undefined. Well, how is cotangent related to the x and the y values of the ordered pairs? Cotangent is the reciprocal of tangent. Remember, tangent is sine over cosine, so cotangent is cosine over sine, aka x over y. So which of these ordered pairs would give me undefined if I take the x value and divide it by the y value? If I take the x value and divide it by the y value. Well, it could be this one, right? Because negative 1 divided by 0 would be undefined, and 1 divided by 0 would be undefined. So we're left with those being the possible answers. But they gave us another piece of information, and that'll help us decide between the two. Out of those two angles, which one is between pi over 2 and 3 pi over 2? Well, label your angles, right? They're saying that the angle that we want is the one out of these two choices. We want the one that is between pi over 2 and 3 pi over 2. So that means we're going to be working with this guy, not this one. All right, let's see if that's enough for us to answer the question. Can we find the cosine of that angle? Oh, yes, we can, because guess what? Cosine of theta is the x value of negative 1 comma 0, which is negative 1.